Okay, my name is Martino. We did a brief introduction at the beginning, but I'm going to talk a little bit about functional programming in JavaScript. So just to get real quick into it, what is functional programming? And kind of like this textbook example that Wikipedia helped me a lot with is treating computation as the evaluation of a number of mathematical functions. And that's kind of contrasted with imperative programming, which would be where you kind of list out the steps you want to go from the beginning to the end, which is traditionally, I think, how most of us were taught nowadays. So some of the core concepts of functional programming would be avoiding state, or encapsulating the state and avoiding mutable data, right? And this is all not just to be a pain in the butt, but it's because it makes your code easier to reason about, and it makes it easier to understand. Sometimes it makes it a little more complicated to write. And some popular languages that are functional are Lisp, Scheme, Racket. There's a million of them. So just some basic ideas before we look at any actual code is the idea of first-class functions. So that's going to be the idea that you can pass functions as parameters or return them from functions. It's actually me. Oh, maybe not. So as we program in JavaScript, we're probably more accustomed to seeing this because any sort of callback, we've seen one of these two. The first one being jQuery, the second one being Node, right? So that's an example of functions as first-class citizens. You're passing in a function into a method. So yeah, not every language has that. And more programming languages are implementing functional ideas.
If that's what's meant by function, then is that you're passing functions along.
Right, instead of, because normally in imperative programming, maybe you'll send some data to a function and it will return like a primitive or an object. Right. But it's pretty rare in imperative to return a new function or to iterate using a function. The other biggest idea is this idea of pure functions, which is simply functions that have no side effects. And this is in functional programming what we strive to, as many functions as we can to be pure. So and that also leads to the idea of referential transparency. So if your function, if it has no side effects or negligible side effects, like logging or something, so if your function takes a certain set of inputs and it will always return the same value from those, then it's referentially transparent. And that just means that you can, when you're reasoning about your code, substitute in that value for the function. So it makes things very easy to see where the problem is, and it makes it very easy, like I said, to reason about things. And another core idea in functional programming is partial application, which is really cool, but I'm not going to talk about it today. So in JavaScript right now, JavaScript is arguably the largest functional programming language that's around, just because it's one of the biggest programming languages. And the things that make it functional is that it has first-class functions and it has closures and anonymous functions. And in the current, the version 1.6, they added in array prototype. So they added in some of these iterators that you use in functional programming, like every sum filter for each map, those sorts of things. And then in the ECMAScript proposal for the next version, there's even more functional constructs that will make things easier for us, but that's a little bit farther down the pipe. There's, of course, some shortcomings, like there is in everything with JavaScript, right? So we don't have, I think I've meant to say implicit returns. Like you have to literally state if you want to return something, otherwise it's just assumed to be undefined, whereas most of the other functional languages, it just assumes the last, I think even Ruby, just the last thing that's in your line, that's in your function, that's the return, which is very nice when you're dealing with all these very short, very concise functions. And we don't have right now any official functional iterators for the objects, only for arrays right now, which kind of leads into the libraries, which there's a few. The only one that I really have experience with and I use extensively is _JS, and it just kind of polyfills a whole bunch of methods because it's meant for front end, so you can have it in old versions of IE, that sort of thing, but it also gives a lot more. It gives those object iterators that we don't have, and memorize, all sorts of things. It even has a small templating engine, which is really weird that it's in there, but it's cool. And functional JavaScript, I was looking at the library. It's really cool. It gives you functional string literals. It's interesting. It just seemed like a little bit much. So these are like the building block methods that you're going to use all the time. So kind of as the imperative for loop and while loop. In functional, we try not to use those. So instead we use these iterators. For each is basically going to call whatever method you sent in on each value, right? So if you ran that, you would get an alert box with the 1, then an alert box with the 2, an alert box with the 3. Map is going to be similar, but it takes the return from that function and it generates a new array with it, right? So it goes to the 1, and then it runs that function. In this case, we're doubling it, so it returns that. It'll go to the 2, run the same function, double it, go to the 3, double it. So then at the end, it's going to return that doubled array. So it's going to return that 2, 4, 6. So this is used immensely. Like I said, it's similar to like a for loop or a while loop, where it's just something you use whenever you have data to go over. Yeah, because that's the idea with functional programming, is you're just transforming this data little by little with specialized small functions. And reduce, again, it's vaguely similar to map, where it takes that return value, but it keeps like a running total, right? So in this case, I wrote a function that's going to combine all the elements, add all the elements of this array together. So, and you see that has a second parameter in there that's 0, and that's what the running total should start as, right? So it'll take that 0, add it to the 1, then it'll run the function on 2, so it's going to take that 1, add it to 2, and then running total will be 3, so then it runs again, 3 and 3 is 6. And there's all sorts of other cool building blocks. Like I said, if you work with _, they have these built in, super tested. So really easy to use: filter, sorting, all those sorts of things. Okay, so I have a few examples because that's the only way to really understand. This is a very theoretical thing. So let's see. Oh, and this was just a little example I made of what I mean by referential transparency, right? If I have a way to just do some synchronous AJAX, right? In this method here, you would run the AJAX method beforehand, send it in, and then that referentially transparent method, you can very easily see exactly what it's doing because it only does one task. Whereas the other one, it's you call it, and then it's going to fetch the AJAX for you and then do the task. So it's doing 2 tasks at once, right? So this AJAX could return a number of things, and that function has to handle all those cases. So you can't assume from the data that you put in what you're going to get as a response. Whereas on the first one, you can say whatever this AJAX sent, or this AJAX data is, when you pipe it in, it's one piece of data gives you one response, because there's no side effects. Let's see. Okay, the logging. So this is a quick kind of logging method that I wrote up. So the idea here is that first you have just this logger that has no function, and you can pipe in what method you want to use as the logging. So right here, you could make your own. I used console log for one, I used alert for another, right? And then regardless of what that is, it's going to pipe in when you actually go to use it. So depending on how you declared and set log, which is now a method, it's going to log. So, you know, whether that be a method that you just send it to Ajax, or appending to the DOM, or alerting your console, or if you have some other way, if you write up a method to do a file rate, right? It would all work, right? And you don't have to pass settings in every time you use it. You set it once, and then you have your logging method. All you have to do is send in strings. So this templating one it's super simple. The idea is if you've ever done heavy front end apps, you have your data. So up here I have kind of my it's an array of fruits and attributes about the fruit. So I think I put name, color, price. So you can see this first one over here is an apple. So then if I were to template it, using an imperative solution, you know, you would just loop through it and kind of concatenate. Let's see. This one. You just loop through the list of fruits, and then you're putting the strings in, and then adding it all to the HTML. But in this functional way, I have one function that its entire job is to deal with taking one fruit and returning it templated. Right, so the first thing I do is I take this list of fruits and I map it with that template function. So that goes through each one and it templates it all how you want it, and it returns you an array of now templated strings. And then I go through and I run a reduce so that, if you remember, it iterates through them all, and it has like that running count. So I concatenate it all down into one string. So then you have all your templated data. So each one of these items, it's very clear what they do. It's very hard to make that mistake of, you know, having that state that's somewhere that's being read inside a function. All these things, you know, when you pass in one fruit item, it's always going to return that same template string, right? And when you give it one array with certain strings in it, you can tell exactly how it's going to squish it together. So that's the idea of making things easy to reason about. Whereas the other one, it's kind of a big blob. You know, there's little numbers that could get mixed up. Okay. And then I wrote this grouping method, just this top one for now, just to show how easy it is to build a kind of one of these building blocks on your own. You know, just like map, it's a very simple function to make. So I made a group by function, and I used that same fruits array. So the idea here is you pass in a function of how to group these things. So, for example, you pass in a function group by color. Group. Right, so it's that simple. Once you have that group function, it's gonna take this the grouping function, right, and loop through, and over here it runs that function on each piece of data so that I can sort it through. And then if we run this, no. So we can actually run this, and we can do group by fruits. Right, and it returned us our array, our object sorted by, there was one fruit in there that was red, there was one that was, or there were two that were yellow, and then in the data you can actually go through and see the red object, or the orange object was an orange. So, I mean, it's a very small function, and I'm sure you can see how it has a lot of flexibility, and that's the idea. So even further, I built upon it by making a sort by method that basically sends the same things to the grouping method and just kind of smashes it down to have it sorted. And I don't want to get too into what each line does, because I used like a couple little tricks to make things not quite so long. Specifically that like weird apply to grab the biggest number. But if I go here and I make a function group by price, group.price, then we throw this in here and do sort by fruits. What was it? Group by price. That's not good. Well, it worked last night. So yeah, the idea of the function is that it queries that group by with the same data, and it turns all those keys into integers, and then it loops down from the highest one to the lowest one, and it puts them all in order into an array. So again, having these sorting functions that you can pipe in to sort by any sort of way that you need, instead of just assuming that you know, when we were writing our merge sorts, you know, in class, everything was supposed to be numeral indexes. You can group by any sort of object. And then I think this last slide. This last slide was actually what made me think of talking about this. A friend of mine asked me to solve this particular problem with him, and so when I compared my approach to his, they were like really different, because he had, you know, that standard imperative approach. So I have his approach in front of me, if I can. So the problem is you have this grid. So you want to take lines of 4, either diagonally, horizontally or vertically, and multiply those together and see what the biggest number is, right? So his approach is probably what a lot of people would do, and he just kind of looped through it, right? It's a mess of a code that nobody would want to maintain, right? He loops through each one, right? And he goes from this point, he tries to find 4 out that way, he tries to find 4 that way, and then just keep this big long list of, like, or not list, but this big state variable of what's the highest, and then continually go and hope that he doesn't hit the edge, right? And I'm sure, like I said, nobody wants to inherit this code to maintain. You know, it's kind of scary. You're kind of sitting there in the debugger, like on line 3. You know, so. And then my approach that I had done, I took was way different, because I was approaching it functionally. So the first thing that I do is I made a method that will pull out just 4. It'll take that big matrix and it'll make small matrices of, in this case, 4. So 4 by 4s, and then I can take those 4 by 4s and run check methods on it. So I have a list of check methods. So I have one for across, one for down, one for diagonal. So then I could just map those, reduce those, boil all the data down, just keep iterating over it. So I don't have that tedious start here, go out, then go down. Then I just have these arrays. So this subgrid, like I said, this will generate me. I pass in the big grid and how far, how big of smaller grids I want. And you can test this. It's very easy to double check that this is doing its one job very, very well. So you can see in this largest product is what actually calls everything. It does that, and that's all it has to do. And then I take that big array of these smaller grids, and then I map that to all the checks that I made. So right now I have those 4 checks, the one for across, down, and the 2 diagonal ways. But the thing is, you could make as many. You could make checks to do squares if you wanted to make things more complex. The system doesn't matter because one thing is not waiting on something else. It's all very isolated. So I have this mapping method, and this is all it does. It just takes that subgrid is what it pulls in, and it runs a map on that with the list of different checks that I need to do. So there's no worrying about when you go to add more checks in, there's only that checking method, right? All I need to do, this check, the vertical check, all it does is it's one job. It just checks across or down every item of the grid, multiplies it together, sends it to you. If it comes into an undefined, which it can, it just returns 0. So it does that one job very well, and it can be all piped together very cleanly. From there, we have just one big array of the values from the check. So we just go into that idea of reducing things down. So here, we made the small grids, we did all our checks, and then we take that, and I made this method for finding the max out of an array, and doing it without using apply. So instead I just reduce it down. So if you have a list of 3 numbers, a 2, a 1, and a 3, I just reduce, and I use that kind of running total to compare the current total, or the current highest to the current number, and just keep reducing it down. So you do that twice, and you wind up with the largest product on the grid. So it's definitely not as fast as the imperative solution, but this code, while it's a little bit obtuse, it's much easier to see where the problem is. It's a lot easier to expand upon or retract, and that's the whole idea. Yeah, that's.
Well, there's probably still optimizations that could be made to it to speed it up too.
Absolutely, but iterate.
Sacrifice speed for functional programming at every point.
Yeah, but there's no way around iterating over the data that many times. Going and iterating once just to find matrices, small matrices, and iterating over those. It's not even going to be close, but there's that balance.
Something similar to this, to that first piece of code where you did it non-functionally and just pretty much all in one while loop.
Yeah.
That code that looks very, very, very similar to that.
And then when you come back, like a couple months later, you just rewrite it, right?
I can't. So
yeah.
I literally can't even debug it. It's getting so crazy.
Right.
I have to step through the debugger.
Exactly.
Fancy breakpoints and stuff.
Well, that code has no lifetime because after nobody's going to be able to inherit it, right?
Yeah.
Yeah, and like the thing is, like it's not like one or the other. It's not functional, or you find like kind of a way to like mix it together in a style that works for you, and if you're working on something substantial, you're working with other people. So something that they're gonna understand, like the code I showed was like extremely functional, probably like a little cruel to put on your teammates, right? But you know, there's a mix, and you know, a lot of the times functional is put at odds with object-oriented. But again, you could find that optimal 60-40, 40-60.
It's like the balance when you're doing object-oriented programming too, between static concepts and non-static concepts, where you've got these RESTful APIs and static concepts where you're literally just using functional programming. You're essentially doing it. You might not be passing in funcs or actions or things of that nature to it, but you're essentially doing functional programming when you're building out those scenarios. Mm-hmm. It's the same kind of tenets.
Yeah, and it's very much the ideology behind Linux. You know, Linux programs like make one thing, make you do it well, and you can just pipe everything together, and you know it all comes together. So yeah, so that's all I have. Thank you.